In this video, I'm going to talk through the worked out solutions to the Unit 0 review. And Unit 0 is all about describing distributions, or box plots, histograms, and then measures of central tendency and range. So for number 1, it says the weekly salaries of 6 employees. So the fact that there's 6 employees, I know that's going to be important. And McDonald's are all of these guys. For the 6 salaries, find the mean, median, and mode. And it says round to the nearest hundredth. And I know the nearest hundredth, we're going to keep that in mind, is 2 decimal places. Alright, so for A, to find the mean, I know that I add up all the numbers and divide by the total number of numbers that I have, in this case 6. So I'm going to do 140 plus 220 plus 90 plus 180 plus 140 plus 200. I'm going to divide all of that by 6. So when I do that in my calculator, I get 770. Oh, you know what? I made a mistake. That should be 220, not just 20. So I'm going to go back. Oh, I can't go back up there. Shoot. 140 plus 220 plus 90 plus 180 plus 140 plus 200. 970. So I get 970 divided by 6 is equal to 161.6 repeating. But it says around to near 2 decimal places. So if I look at that, if I go to the hundredth spot, I go back one, that's 6 is 5 or greater. So I'm going to round this up to 7. So this is approximately $161.67. And when I look at that, that answer makes sense because all of these are, looks like 161 would be about in there. There's no really outliers pulling that in one direction. All right, so for B, the median, and I have to list these in order. The lowest is 90. And then we have 140. Looks like we have 140 again. 180, 200, and 220. Just to make sure I didn't miss any numbers, I'm going to count them. 1, 2, 3, 4, 5, 6. Yep, 6 numbers. That's what I started with, so I'm good to go. And the median is going to be in the middle. So as I start working towards the middle, I'm left with 140 and 180. When I have 2 of these, that means I have to add them up and divide by 2.
Thank you, students, for the first great day of Spirit Week. Today at lunch, we will be doing a football toss game. Also, we will be selling homecoming tickets. Get yours soon, they're about to sell out. Tomorrow is America Day, where all the red, white, and blue you can handle. Let's show the world that Canton loves the USA. Thank you, and have a great day.
Sorry for the interruption on that. So when we add them divided by 2, we get 160, which makes sense because 160 is right in the middle of 140 and 180. So that would be the median. And make sure our units on there are the same units as the problem had originally, dollars. C, finally, we're doing the mode. The mode is what number appears most often. So when you look at that, the only number that appears more than once is 140. So the mode would be $140. Moving on to number 2, it says Andy has grades of 84, 65, and 76 on 3 math tests. What grade must he obtain on the next test to have an average of exactly 80 for the 4 tests? So we know we have 84 and 65 and 76. We're talking about the average. We want to be 80. So if we add these up and whatever he gets on the next one and divide by the total number of tests he has, and at that point he'll have 4 tests, that will have to equal 80. So some number on top divided by 4 is 80. Now if I don't know what that number is in my head, what I can do, I can multiply 4 times 80, and that'll mean that is 320. So 320 divided by 4 is 80, if 4 times 80 is 320. So this number up here has to be 320. Well, when I add up these 3 right now, that ends up being 225. So 84 plus 65 plus 76 is 225. Plus some number, that has to be equal to 320. Now, if you can do that mental math in your head, that's great. But if you can't, I can subtract 225 And the score on my next test will have to be whatever 320 minus 225 is, which is 95. So this is the score on the fourth test. So the score has to equal 95. We can double check that. If we add these up, 84 plus 65 plus 76 plus 95, and I divide by 4, that gives me an average of 80. So we're good to go. Moving on to number 3. In January of 2006, your family moved to a tropical climate. For the year that followed, you recorded the number of rainy days that occurred each month. So every month, and there's 12 months, we record how many days was it rainy. So looks like in January it was 14, and so on. So let's find the mean, mode, median, and range for your data of the rainy days. So the mean, we would take all these numbers, add them up, and divide by, in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I would do 14 plus 14 plus 10, 12, 11, 13, 11, 11, 14, 10, 13, 8. I get 141. I now divide by the 12, and I get 11.75. And when I look at that, yeah, that looks like it would be reasonable. There's some above, some below. Okay, so the mean would be 11.75. The units on this, well, we're talking about how many days it's rainy, so days. So on average, it's rainy 11.75 days a month. The mode, the next thing it asked me, is the most common. When I look at this, 14 appears 1, 2, 3 times. Got 10 appearing twice. 11 appears 3 times as well. So 14 days and 11 days. We have 2 modes in this situation because there's 2 days, or 2 numbers that show up 3 times. And then our median, well, to get the median, we have to take these numbers and list them in order. So I have the lowest one is an 8, so I would have 8, and then is 10 the next one? Yep, 10, another 10, and then we got 11, 1, 2, 3 11s we said, 11, 11, 11. And then we're moving on to 12, just 1 12, and then looks like 2 13s, and then 1, 2, 3 14s. 1, 2, 3. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 total. Now we could go back and forth. I want to talk about this one, a different way to find the median. If there's 12 total, I know that half of these numbers have to be above the median and half have to be below. So half, if I take 12 and divide by 2, that means 6 will be above and 6 will be below. So I can go to 1, 2, 3, 4, 5, 6. These 6 will be below. These 6 will be above. All right, so the median will be somewhere in the middle of these two. Again, you could have gotten it by crossing out, but I want to show another way of thinking through this. So what number is in the middle of 11 and 12? Well, that'd be 11.5. Or you can do what we did before and do 11 plus 12 divided by 2, which is 23 divided by 2, which would be 11.5. So the median would be 11.5 days. All right, and then finally the range. The range is always your maximum minus your minimum. The highest number is 14. The lowest number is 8, so when I subtract them, I get 6. Again, the units are the same, 6 days. So here are the 4 different numbers or values that problem asks for. Down here it says if there are 3 more rainy days every single month in the year 2007 than in 2006, what will these values be now? So mean, mean, and mode for this situation. Well, all that's saying is that each one of these is 3 more. So instead of 14, 14, 10, we'll have 17, 17, 13. Okay? So what you can do is you can go back and do all the same calculations for that. I'm going to think about this just the idea. If I add 3 more to every single one, it's just going to shift all of these values up. So instead of 11.75, it's going to be 14.75. Instead of 14 and 11, the most common number will now be 17 and 14. And the median, because all of these will be 3 more, it'll all be shifted up. So instead of this being 11 and this being 12, it'll be, let's see, so 14 and 15, and the number in between 14 and 15 would be 14.5. So your mean in this case would now be 14.75 days. Your mode will now be 3 more, so 17 days. And 14 days. Your median will now be 14.5 days. And the truths are the same is true of the range. Instead of 14 minus 8, we'll have 17 minus 11, which is still 6 days. So the range is different. Your range is not 3 more. It would be 17 minus 11, which is still 6 days. So what's interesting is that your measures of central tendency all get shifted up 3, but the range actually remains the same because the measures of central tendency talk about the middle, and if you add 3, you shift to the right 3, so all the middle gets moved up. But the range goes from max to min, and if you shift everything up, that range, that difference, doesn't change. All right? Switching on to number 4. You have these test scores for 20 different students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Ooh, 21. Why do we call that? There's 21 students. So make a frequency table for the data. All right, so I'm just going to go through here. 93 would fit in here. 84 is right here. 97, 98, 100. 100 is a tricky one. So 100 shows up in 2 intervals, but remember, once you get to 100, it gets bumped up to the next interval. There's the equal to, so the 100 is going to go down here. 78 is here. 86. 100 again is going to bump up to that next interval because we have the equal to down here. 85 will be here. 92. 72. 55. 91, where are you at? Here. 90, again 90 is in 2 of them, but once you get to 90 here, you get bumped up because this is less than 90. This would be the number is greater than or equal to 90, so 90 will be in this one right here. 75, 94, 83 is here. 60 again gets bumped up to the next one because it's equal to 60 here. 81, 95, and 82. There we go. All right, so we have 1, 1, 3, 6, 8, and 2. So we can write these numbers if we want. 1, 1, 3, 6, 8, 2. Find the interval that contains the median. Okay, now we could list all of these in order and then mark them off. That takes more work than I really want. So let's do it the way we were talking about before. If I have a total of 21 students, and we can even count this, we have 8 plus 2 is 10, plus 6 is 16, plus 3 is 19, 20, 21. There's a total of 21 students. I know that half will be above the median, half will be below the median. So if I divide that by 2, I get 10.5. That means 10 of these will be below, 10 will be above, and then that 0.5 tells me that the number in the list will be the median. All right, so if we look at this, there's 1, 2 total. Now once we get to here, we have 5 below this number. Once we get here, we have 11 below. Okay, so the 11th number will be in this interval. Look in here, there's 10 below here. So the 11th number has to be in this interval. So the interval that contains the median would be 80 less than or equal to x less than 90. The 11th number, if we listed them in order, would be in that interval. And again, you could have listed all these out and figured out what number it was and know that, but this would be a faster way to do it. Switching up here, create a list of numbers that has a median of 15. So it doesn't care, we don't care how many numbers it has, but we need a median of 15, a mode of 7, and a mean of 13. Okay, so if I want a median of 15, my thought is, well, let's just start with an odd number of values and have the median right in the middle. So we know we're going to have 15 in the middle. We need a mode of 7, which means 7 has to appear more than once. So let's put 7 here and here. Now I'm putting them to the left because they're less than 15. So then I'll also need 2 numbers to the right. In order for 15 to be a median, it has to be in the middle when they're written in order. So now what I'm thinking is when I add up these 5 numbers, They have to all add up, and then when I divide them by 5, it has to equal the mean of 13. Okay, so this is where I'm getting the 13. The mean is 13. Well, I'm thinking, well, what number divided by 5 is 13? If I don't know what that is in my head, I can go to a calculator and say, well, 5 times 13 is 65. That means 65 divided by 5 is 13. So this number up here, the way we have this set up, would have to be 65. There's a lot of different ways to do this, but this is just one way. So if all the numbers up top have to add to be 65, well, I can start adding these up and see what I have already. So in this case, 7 plus 7 plus 15 is 29. So these two left over, I only have whatever 65 minus 29 is. I only have 36 left to fill those two spots. Well, I can't have 15 because then the mode won't be 7. So we have to go one up and be 16. So let's subtract 16. When I subtract 16, I have 20 left, which means this number has to be 20, because in order for all of these to add to be 65, that number has to be 20. So now, if I divide those by 5, I get the mean of 13, so that works. The median is 15. If I cross them off, the middle number is 15, and the mode is 7. I meet all those requirements. So my list of numbers is 7, 7, 15, 16, and 20. There's a lot of different possibilities here, but that's just one approach I took. The next one says create a list of numbers that has no mode and a mean of 25. Well, if there's no mode, that means that no number should appear more than once. So let's just do a list of 4 numbers. 1, 2, 3, 4. I have to have 4 numbers, since I'm just choosing 4, it doesn't matter, it doesn't tell me how many, that has no mode, which means all of these numbers have to be different. And the mean is 25. Now remember, a mean of 25 means that when I add these 4 numbers and divide by 4, I get 25. I'm thinking, what number divided by 4 is 25? This one I actually remember. I know in my head, because there's 4 quarters in a dollar, so there's 100 divided by 4 is 25. But again, if you didn't know that off the top of your head, you could do 25 times 4, which is 100, which means 100 divided by 4. Oop, no, 100 divided by 4 is 25. So this number right here has to be 100, which means these all 4 have to add to be 100. So I can choose any 4 numbers that add to be 100 as long as they are different numbers. Well, let's choose 1, 6, 28, and then let's see what's left over. 1 plus 6 plus 28, I get 35. So whatever is left over, 100 minus 35 is 65. So if I add these all up now, I should get 100. 1 plus 6 plus, what's the number? 28 plus 65 equals 100. To find the average, I divide that by the 4 numbers. I get 25. So my numbers, 1, 6, 28, and 65 would be a list of numbers that has no mode because none of them repeat more than once, and a mean of 25. So when I add them up and divide by 4, I get 25. But again, there's a ton of different ways you could approach this. Flip into the back. It says use the box and whisker plot to solve. Okay, so we have this box and whisker plot. We're talking about the length of Best Picture winners. Okay, and these are all in units. So for A, the shortest film to win an Academy Award for Best Picture was Marty, which won the award in 1955. They're just giving us some information. How long was this movie? Well, it says it's the shortest, which I know that's telling me to refer to the minimum. And on here, I know the minimum is this lowest value. So 30 minutes. Part B said, is the median time for Best Picture winners greater or less than 2 hours? And by how much? Well, the median is, of all these guys, is this number right here. Remember, that's the min. This is the max. You have the median, you have the lower quartile, which is the median of the lower half, and you have the upper quartile, which is the median of the upper half. So the median is 76 minutes. So the median is 76 minutes. It wants to know, is it more or less than 2 hours? Well, 2 hours, if there's 60 minutes in an hour, then 60 times 2 hours would be 120 minutes. So the median is less than 2 hours, and if I do 120 minus 76, 120 minus 76, I get 44 minutes. So it is less than less than 2 hours by 44 minutes. For part C, one film reviewer looked at this box and whisker plot and wrote about 25% of all Best Picture winners are more than 1 hour, 42 minutes. Do you agree or disagree? Well, I know that 25% are more than, so let's look up here. We know each one of these represents 25%. So the top 25%, 25% are above the upper quartile of 102 minutes. So 1 hour and 42 minutes, well, 1 hour is 60 minutes plus 42 minutes equals 102 minutes. So I agree. I agree because 1 hour and 42 minutes is equal to 102 minutes, which is the upper quartile. And 25% of the movies are greater than the upper quartile. All right, moving on to D. Cleon wants to find out what running time is shared by most Best Picture winners. Can he use this box plot to find that answer? Why or why not? So the most common running time is really what it's asking for. That's just another word for mode. So really the question is asking, when you look at a box plot, can you find the mode? Well, unfortunately, the box plot only gives us the min and max, upper and lower quartile, and the median. So in this case, no, you can't, because you don't have a list of the actual values or the actual minutes. So can you use it? No, because the box plot does not provide specific data values. And that's what we would need in order to find the mode. Scooching down here, was there a length of blank? Okay, let's look at this. So 50 minutes. 50 minutes lies somewhere between the minimum and the lower quartile. It's on this range, or in between here. So it's possible, because it could lie in the whisker, but it might not be. So this one is a maybe. 76 minutes is the median. Now the median is only a part of the data if it's an odd number of data values. If it's even, it might be part of the data values, it might not be. Because it doesn't tell us how many winners these are, this is also maybe, we just don't know. 126 minutes, now that's the maximum. The maximum and minimum are actual data values, we know that. So the maximum, yes, it has to be. And if it were 30, it would also be yes, it has to be. Now those are the only two that you know for sure, unless you know that there's an odd number of data values, in which case the median would also be part of the data value, or part of the list of numbers. And then finally 140. Now 140, it's on the number line, so sometimes I want to jump to saying yes, but the box plot is what represents the lengths that we're talking about, the lengths of the movies. So the maximum is 126, so none of them were 140, so this one is no. Scooching down here, which statement is not true about the box and whisker plot shown? A person could make $22 a day. 22 is here, that looks like the minimum, so I would say that is true. A person could make $30 a day. 30 lies here, that's not true. Or sorry, that is true, so it's not the answer. A person could make $26 a day. Well, it falls inside here. So yes, that could also be true. We don't know for sure, but it could be true. So the last one, all the statements could be true. Yep, that's it. All of those could be true. Based on the bar graph to the right, to the nearest whole number, what is the mean number of seeds per apple? So we have this bar graph. It's not a histogram because we don't have the intervals, but it's a bar graph, and it says the number of seeds in each of 12 apples. So this is the number of seeds, and then, or this is the number of apples that have this many seeds. So of the 12 apples, 2 of them had 3 seeds. 4 of the apples had 5 seeds, and so on. So this is 2, this is 4, 1, 2, and 3. So you can think of this a couple different ways. If you really want to like write out the whole list of numbers, if I have 12 apples, 2 of them have 3, so I could say 3 and 3. 4 of them have 5 seeds, so we would have 1, 2, 3, 4. 1 of them has 6 seeds, so we'd only have 1 6. 2 of them have 7, 7 and 7, and 3 of them have 9, 9, 9, 9. That was a total of 12 apples. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what I can do is add all these up and divide by the 12 apples to find the mean. So if I do that, 3 plus 3 plus 1, 2, 3, 4 5s and a 6, 7 and 7, 1, 2, 3 9s, I get 73. There was a total of 12 apples, so I'll divide by 12. So that is approximately 6.08. It says to the nearest whole number. The nearest whole number would be the ones place. So 6 seeds per apple. All right, and moving on to the second page, number 10. Joshua, sophomore at this high school, usually goes to bed around 11 p.m. and gets up around 8 a.m. to get ready for school. That means he gets about 9 hours of sleep on a school night. He decided to investigate this statistical question. How many hours per night do most sophomores usually sleep when they have school the next day? So he surveyed 20 sophomores, and then he has this data set. All right, so we got 20 sophomores, and we can now make a histogram. So let's make a histogram. So where do we go? So 7, when it equals 7, it jumps up here. 8, 5 is down here. 1, 2, 3 9s, so they're all beat up here. 1, 2, 3. 2 7s, so 1, 2. 2 10s, 1, 2. An 11, jump up to this guy. A 9 will be in this one. 1, 2, 3 8s. 1, 2, 3. A 12, a 6, an 11 jumps up here. A 9 is here. And 10 would be in here as well. All right, so we got 2, 7, 8, and 3. To make a histogram, down here, I'm going to have labeled this as the number of hours of sleep. And then here would be the frequency of sophomores, so how many sophomores are in that interval. It gives us the interval. So we'll start here at 5, 7, 9, 11, and 13. It stops there, so I'm not going to go any further. And then we'll go by ones. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So from 5 to 7 is 2. So I'm just going to take my highlighter because it's easier to do this with a highlighter in my opinion. So highlight in 2. From 7 to 9 was 7. From 9 to 11 was 8, so I'm up to 8. And from 11 to 13 was 3, so back down to 3. All right, so, oh, we also need a title. Let's title this Sophomore Sleeping Habits. Okay, so moving on, it says, what information can you get from the histogram? Well, there's a lot of information you can get from the histogram. If I ignore this, here are some examples. I'm not going to write these down, I'm just going to talk through them. I would say of the 20 sophomores, most sophomores slept between 9 and 11 hours of sleep. No one got more than 13. We know that for sure. No one got less than 5. So you could say all of those things, all right? A lot of different possibilities. You could even find percentages. So if this is 2 and that was 7, this was 8 and this was 3, I could say, well, let's just choose this one. 3, so 3 divided by, there were 20, 15% got between 11 and 13 hours. Well, let's just say great 9 hours of sleep or more, so that's 8 and 3, that's a total of 11. 11 out of the 20, so 55% got at least 9 hours of sleep, because anything greater than that. So there's a lot of possibilities there. For C, what information can you not get from the histogram alone? So if you were only given the histogram and not the data, so ignoring all of that, you just were given the histogram. Well, when I look at this, I can't find things like the median or the mean or the mode or the range. None of those I can find because I don't have the specific values. All right, so I can't say the mode, well, this interval has the most, so between 9 and 11, but I don't know what numbers they actually were. So those are the things I cannot get, or examples of things I could not get. Part D says, make a box plot. Well, in order to make a box plot, I have to list these numbers in order. So these numbers in order would be 5, 6, 7, 7, 7. We had 4 8s. And then, what's it, 5 9s? 1, 2, 3, 4, 5 9s. 3 10s. 2 11s, and a 12. To make a box plot, I need the 5 numbers. I need the max and min, the median, and the upper and lower quartile. I always start with the median. Well, if there's 20 numbers, I know that there will be 10 above the median, 10 below. Or I could cross them off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these 10 will be below, these 10 will be above. Or if I cross them off, and I keep working my way, I would end up with these 2 in here. So the median is 9. Well, now I find my lower quartile. The lower quartile is the median of the lower half. So ignore the upper half right now. The median of the lower half, well, if there's 10 below here, that means 5 will be below the lower quartile, 5 will be above, so 1, 2, 3, 4, 5 will be here. Or, you could cross these off until you get to here. Now, what's in between 7 and 8? Well, that'd be 7.5. Or you can add them together and get 15. Divide by 2, that's still 7.5. So the lower quartile is 7.5. If I do the same to the upper quartile, bloop, 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 bloop. Land here, well, in the middle of 10 and 10 is just 10. So the upper quartile is 10, or you have 5 above and 5 below. And then finally, the minimum is 5. The maximum is 12. So now I need to make my number line in order to graph this. So I'm making my number line. Let's start with, we'll just do 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So here's the number line. Now I plot these points. The minimum was 5, so I plot 5. The lower quartile was 7.5. The median was 9. The upper quartile was 10, and the maximum was 12. So I make my box with the upper and lower quartile, and then I have my whiskers. Now again, we always label these, so we have this as 5, 7.5, 9, 10, and 12, and I made my box plot. What information can I get from the box plot? Well, if I only look at the box plot, and I'm not looking at these, the information I can still get, well, I can identify the min and max, I can figure out the median, I could tell you that 25% sleep greater than or between 10 and 12 hours. I could say 50% sleep between 5 and 9 hours or less than 9 hours. I could tell you what the median is. I could find the range if I could know the max and the min. Things I can't tell you if we look onto F, I don't have the actual number values if I'm just looking at the box plot, so ignoring that. So I couldn't tell you things like the mean or the mode. I do have the median. I could find the range. So I can't find the mean and the mode though. All right, and flipping to the back, Last problems here. Describe the relationship between the mean and median for the histogram and how you know. So the essentially saying, is one greater than the other, or are they approximately the same? Well, when I look at this one, I don't have any numbers here, so I can't actually calculate where the median might be or anything like that. But it looks about the same on either side. This kind of looks like a normal distribution or normal skew, meaning I don't see any outliers. So I would say because there are no outliers, the mean and median will be approximately the same. And they'll be right about in the middle. However, so we'll find right about there. When we scooch over here, this guy has some outliers over here. So because they're outliers, I know that the median will be around the tallest bar, or probably somewhere here. So this is the median. But the mean is biased towards the outlier. So these outliers pull the mean. So the mean might be somewhere over here. So in this case, the median will be greater than the mean. So the median is greater than the mean because the mean is biased to the outliers. And in this case, the outliers are to the left. And there we go.